Hello, everybody. Today you are going to finish up the population sections of your notes in Edpuzzle. We're going to talk about carrying capacity, limiting factors, and some population dynamics. So I know it was some time ago, but if you remember from the last Edpuzzle on populations, we talked about births, deaths, immigration, and emigration, and how each contribute to the overall growth of a population. So births and deaths, individuals are born or they die. Births will increase the population, deaths will decrease the population. Immigrants are individuals moving in, immigrants in, and immigrants, individuals exit. So immigrants will increase the population and immigrants will decrease a population. And then you also did an activity in which you looked at the birth rate and the death rate, and you discovered that if the birth rate was greater than the death rate, the population was going to increase. And this can also include immigration. If that's bigger than emigration, the population will increase. And then if the death rate or emigration rate is greater than the birth or immigration rate, the population is going to decrease. So births, deaths, immigration, and emigration are some ways that populations can increase or decrease. What I would like you to do for this question is brainstorm some things that could cause a birth rate to increase, or some other factors that could cause increased immigration. And then I'd like you to also brainstorm what could increase a death rate, or what could increase an emigration rate. Write your answer in the pop-up box on the Edpuzzle. So some things that could cause more births or more immigrants coming to an area are things like more food, more water. If you have more food and more water, you have more energy and can have more offspring. More habitat being available is another reason why individuals might want to immigrate to an area. Fewer predators means that there are fewer animals dying, and so more live longer and can have more babies to increase the birth rate. And then humans also create laws protecting animals and plants that's going to help them increase their birth rate. Or setting up nature preserves is another example that we can do to protect different populations and keep the birth rate high. On the flip side, if there's less food or water, habitat loss, and this could be caused by humans, it could be caused by some sort of natural disaster or some other environmental factor, but any sort of habitat loss could cause the population to decrease. And then if there is an increase in predators to an area, that could also cause the population to decrease. So all of these can contribute to this population size, but we also need to keep in mind that populations don't exist on their own. There are other populations that make up the community. And so the growth or decline of another population can impact the population that we are interested in. So for example, if one animal has a mutualistic relationship with another, and the other animal's population is declining, that's going to affect the animal's population too. It's going to cause the other population to decline. Same with if there's a parasite population increases, that will cause your population to decrease. If another herbivore decreases, that's going to lessen the amount you have to compete with that herbivore for food. And so your population will have more food and can increase. You're going to be looking at some of these scenarios in your activity today and thinking about how the growth or decline of one population can affect other populations. I'd like you to answer this next question in the Edpuzzle pop-up window. So a population of mosquito larvae, or baby mosquitoes, is living in a pond. Mosquito fish are a type of fish that eat the mosquito larvae. Which of the following describes a direct effect on the population of mosquito larvae when the mosquito fish are introduced to the pond? A. Births decrease. B. Deaths increase. C. Immigration increases. Or D. Immigration decreases. The answer to this question would be B. Because if you add mosquito fish, which are predators to the mosquito larvae, more of the mosquito larvae are going to die because more of them are getting eaten by the mosquito fish. One interesting area of study when you look at populations are population dynamics, and this is how populations change in size and structure over time. And the example that we're going to look at in class, and so we'll talk about this more in class, are predator and prey cycles. And so this graph down here shows an example of a predator-prey cycle. What I would like you to do is in the pop-up window, I'd like you to write what you notice or wonder about this pattern here in the graph. What do you notice about the predators and the prey? Or wonder about the predators and the prey? The last thing I want to talk about is carrying capacity. Carrying capacity is the maximum number of individuals an area can support. And this is where the rate of change or the rate of growth is 0. That means the number of births equals the number of deaths, and the number of immigrants equals the number of immigrants. And if you look at a graph that shows what the population looks like at carrying capacity, you see that this curve is created. You see that it increases really rapidly, and then it will start to flatten out as it reaches the carrying capacity. The reason why there's such thing as a carrying capacity is because of limiting factors. Limiting factors limit the size of the population, and these could be biotic or abiotic. Some of the things include the amount of food. So the amount of food is a limiting factor because, if you can't feed everybody in the population, some are going to starve. Amount of space, availability of mates, and also, I'm sorry, it's cut off down here, but the spread of disease too is another one. As populations become bigger and more dense, it's much easier for germs to spread. Those are all examples of biotic factors that are limiting factors. But you can also have abiotic factors too, like water, weather, and climate. Those could also limit the size of populations. And so overpopulation is when the population goes past its carrying capacity. So if this graph were to extend, keep going up, 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 like this. When that happens in nature, Very shortly after that, it's followed by a population crash where the line goes down very rapidly. This is because if you go over your carrying capacity, you run out of food, you run out of space, um, you start spreading diseases much easier, and so that's going to cause a very high death rate in your population and cause it to decrease. And the last thing I want to mention is that if these change at all, so if the amount of food is changed because of humans developing land and building a mall or something, taking up that habitat, and cutting down trees that are a source of food, the carrying capacity is going to be affected of the population that we are interested in. So if these change, so will the carrying capacity. So the carrying capacity isn't a set number. It entirely depends on these limiting factors. All right. Finally, as your exit ticket, I would like you to complete this question, an Edpuzzle. So in 1937, 2 male and 6 female ring-necked pheasants, these are a type of bird, were introduced to an island off the coast of Washington state. The pheasants mainly ate wheat. The only known predators on the island were house cats, hawks, and owls. After 5 years, the pheasant population on the island had increased to 1,325 individuals, and then the population size remained stable. Which of the following most likely explains why the pheasant population size remained stable after 5 years? A. The hawks learned to hunt only owls. B. A limited amount of wheat grew on the island. C. All the house cats that lived on the island died. Or D. The original male and female ring-necked pheasants died. So if you look at these 4 options, the best option is B. It's very unlikely that hawks learn to hunt owls, especially when there's plenty of pheasants for them to eat. It's also unlikely that all of the house cats died. And if the original male and female pheasant died, then, that doesn't affect necessarily all the other pheasants in the area. So we are left with B. A limited amount of wheat grew on the island, and that amount of wheat contributes to the pheasant carrying capacity of 1,325 individuals. So this is the carrying capacity of that island because there's not enough food to go around to support any more than that number of pheasants. And that's why the population remains stable. The graph would look like this graph here. It would increase, and then right here would be when the pheasants remained stable, when that curve flattens out.